Yeah. Alright, so this is the last bit of chapter 5, in fact, for the whole module. Right, so what do we do when we come across a contaminant site? So this is just a recap of where we left off in the last slides. Right, so when we come across such a site, there are two options, right? Normally we have two options. One is that you construct a new engineered site, all the goodies, all the instrumentation, all the safety features, and then you transfer your waste material there and to start remediating the plume by palm, treat, and so on and so forth. Of course, you can see this will be very costly because you are going to construct a new place, a new containment facility for it. The second option, which is more feasible in most circumstances, would be to control the movement of your contaminants from such a site by containment of the waste and also the plume through the construction of physical barriers. And this is where we talk about the barriers. Okay. And the main objectives of having this containment is that to reduce the rate of your transportation of the contaminants, and number two, to minimize the movement of the uncontaminated groundwater from upstream to the contaminated site. So basically to contain the contamination from the spreading. Okay. And then ideal containment will involve four components. You have vertical barriers that are cut-off walls around the circumference of the site. So the site, all around it, you have these cut-off walls that are called vertical barriers. 2, you have horizontal barriers on the top to form the cover, and 3, obviously, you have horizontal barriers at the base to form the liner. Okay, and so you have on the side surrounding the perimeter of it, and then you have the top, then you have the bottom, and finally you have a groundwater withdrawal system using extraction wells. So meaning that if the groundwater is contaminated or stuff like that, then you could actually monitor it by having the extraction wells. So this is an example of how they look like, plan view and the side view of it. So this is your cutoff barrier. Okay, the vertical ones we talk about along the perimeter of your dump site. So when the groundwater comes, the flow, it will not be able to penetrate through your barrier. Alright, you flow around it. But still, we have some extraction wells just in case we see that there's a groundwater will actually penetrate through our barrier. It's a malfunctioning barrier, for example, and we can capture that in our monitoring well to make sure that it doesn't escape to the downstream and start spreading. Okay. So this is how they look like. You can see the plume coming through. Remember, above the groundwater table, we have the unsaturated zone, and once the leachate exceed the infiltration capacity of this layer, then it will start to go down and join our groundwater and start to form the plume. The plume is like the mushroom ballooning thing that will bring the leachate far and wide. Okay. Right, the last bit of this chapter is really about innovation for sustainable solutions, and one is waste reduction. So we are always being reminded that we generate so much of waste, household waste, process waste, waste from agricultural waste, all sorts of waste. And when we dispose them in these landfills, it's not exactly a sustainable solution in the long term because one, you need to excavate a big pit, a big hole to do it. 2, no matter how we line it and install all the safety features, there's still the risk of the contaminants coming out. That is why we see all these monitoring wells, whether it's for groundwater or for the gases, being installed to make sure that the contaminants are not propagating to places that we don't want it to be. All right. And however, apart from the contamination risk, we also have the problem of limited availability of land. If you have ground available, vacant land, if you like, on the surface, that you could use to construct more infrastructure like housing, like roads, rail tracks. But we are using it for landfills. So that is like using land to contain waste. So it's a waste. It's a waste of good grounds. So a more sustainable, stable, long-term solution will be to reduce the quantity of waste, and that is why we start talking about recycling and all. And in terms of industrial waste reduction, we could be achieving that by using more efficient and clean technologies that give you the same productivity, but then give you less waste production. So this could be more efficient materials, more efficient machines, or it could be recycling or reusing the generated waste material. This is more common, and most probably quite a few of the groups here for this course, for the project, would be going down this path as well, trying to reuse some of the waste material. So some examples here: recycling paper and glass as household level, I believe this segregate our waste exercise has already been in place for a few years, but we are not quite aware and not quite practicing it yet. So it's at certain days for plastic, certain days for degradable waste, things like that. But we are not quite there yet to take the trouble to segregate the waste. But maybe, well, to start out with, maybe we should. Plastic bottles or glass bottles. Glass is rare. We don't use that much glass bottles anymore. And paper waste. I think these are easily sorted out. Put one side, gather them in a large bag, and when they're quite filled, just dispose them out, send them to the recycling center, or put them one side outside your bin because they're clean literally. So the garbage collector will know what to do with it. Right? That's we do a little bit. Do our part, no matter how small it is, for the sake of the well-being of the earth. We could actually convert some of the kitchen waste through composting and fertilizing. You probably know about this as well. Is you can buy these composting pots, or you can make your own. Once you put in the correct waste material, biodegradable waste, you could actually produce fertilizers at the end of it, so it's not so wasteful. We could use industrial waste, especially the ashes, to replace, partially replace cement and so on. So fly ash actually comes out from the power generation plant. Okay. And you could be using slags as well. Slags are like rock-like residues from metal processing plants like steel processing. So you can imagine these residues come out mixed up with the rock minerals, and also they are like chunks of rocks that's got elements of metal in it, so they are heavy. Alright, should be heavy and porous. So these are because they are literally rocks, so they could be used for sub-base or road construction, things like that. Okay, but the only concern that some researchers have highlighted is that they could contain the contaminants or toxic compounds in there. So if we are not careful, for example, we use these slag material and they're contaminated, and we use it for constructing roads, and we know roads are not exactly a wrap up confined system. So when the rainwater comes, infiltration into the ground, it could leach out, and these contaminants go into our drains, could go into the river, and it could contaminate our river organisms and fishes, and it could be taken up for irrigation, it contaminate our food crops and so on. So got to be cautious about that. And we can also use waste material in geotechnical construction, and again some of your groups probably have already gone for these approaches. Probably use like recycled plastic, recycled PET bottles, or recycled even all these fibers we're talking about. So I think it won't be a lack of ideas on this. You can look up more on these innovative ideas for more sustainable solutions in waste reduction. Okay, so that's all for the topic in lecture for now. Okay.